Hello friends, we are right now completing a portion called permutation and combination. I told you this is the beginning of a part of a mathematics which is called combinatorics. Combinatorics is basically designed for very simple tasks. In every walk of our life, for scientific applications and otherwise also, we need to count a number of ways the things can be done. So number of ways the things can be done can be calculated by using this particular science of mathematics called combinatorics. So basically we are using two counting principles which I introduced in my previous lectures, but I'll repeat again. First counting principle is called multiplication principle. It says that if there is job 1, job A, and the job A can be done in m number of ways, and job B can be done in n number of ways, then total number of ways in which both the jobs simultaneously can be done is m multiplied by n. As an example, suppose you have a cricket team and there are 11 members, and suppose everybody is capable of becoming a captain and vice captain. So how many ways you can select a captain? Captain can be selected anyone from the 11 members. So total number of ways of selecting a captain is 11, whereas the vice captain cannot be the same person as captain. Hence, there will be only 10 members available because one of them is already gone out of the contention because he is already a captain. So he cannot be vice captain. So there are 10 alternatives available for vice captaincy. So total number of ways of captain and vice captain can be selected is 10 multiplied by 11. Correct? This is called multiplication principle. There is another principle called addition principle. In addition principle, we are using the adjunct as or and not and. In other words, if there is a job A can be done in m ways, job B can be done in n ways. And if I want to do either A or B, then it can be done in m plus n number of ways. Just take an example that there is one class, there are 5 students in that particular class. Another class, there is 4 students in that class. And I ask you, just go and select one student either from the first class or second class. You have already 5 plus 4 candidates to choose from. So therefore, here we are applying addition principle, right? Now, we have also introduced a factorial notation. And number of permutations, the number of arrangements of n objects taken r at a time, we have already seen that it is given by a symbol called NPR, and NPR can be written as n factorial upon n minus r factorial. All these things are covered in my previous lecture. Now we are here to apply the concepts that we have learned in the previous lectures. Now let us look at the first problem in your CBSE book. Okay, and that is what? How many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? Now, when you look at this problem, you have to identify what is n and what is r. Okay, so now here, how many 3-digit numbers can be formed? Now, 3-digit numbers can be formed means it is equivalent to filling up 3 places. So, one first digit, second digit, and third digit, right? So, these 3 digits are to be formed, right? And how many numbers are available? From 1 to 9. So, 1 to 9, there are 9 numbers available. So, the first place can be filled in 9 ways, okay? Because all of them can be accommodated here. But digit is not allowed to repeat. Therefore, one digit which is used here is not available for the next job. Next job can be done in how many ways now? There are 8 alternatives, and third job can be done in how many ways? 7 alternatives, correct? And all these jobs are to be done simultaneously at one time. So therefore, there is a multiplication principle here. So we'll have to multiply the 3 things. So answer is 9 multiplied by 8 multiplied by 7. Okay, so that comes out to be 72 multiplied by 7, which is equal to 4 and 50, because 504 is the answer. But here I have just applied a multiplication principle, but this problem can be done by using this formula also. So here there are how many digits were available? There were 9 digits available, right? And r is what? Only 3 are to be filled. So 9p3, that is another way of solving this problem. So there are 9 digits available, right? 9 digits, out of which only 3 are to be taken and they can be permuted. So out of 9, How many ways 9 digits can be permitted if taken 3 at a time? So the answer is 9 factorial divided by 9 minus 3 factorial. Okay. So that gives you what? 9 factorial divided by 9 minus 3 is what? 6 factorial, which means 9 factorial is what? 9 into 8 multiplied by 7 and multiplied by what? 6, 5, 4, 3, 2, 1. Divided by 6 factorial means 6, 5, 4, 3, 2, 1. So all these factors after 6 will get cancelled. So ultimately you are left with 9, 8 and 7, which is same as this. So the answer is going to be the same thing. So this problem can be solved in this particular manner. Okay. So now let us look at another problem. Okay. How many 4-digit numbers are there with no digit repeated? Now here, the number of digits, the available candidates are not given. That means how many 4-digit numbers can be formed. Okay. So 4-digit numbers are to be formed means I told you, you have to fill up 4 places, right? So this is one job, first digit, this is second digit, this is third digit, this is fourth digit. Okay. So 4-digit numbers are to be formed and no digit has to be repeated. Now you have to start looking at how many digits are available for filling of the first place. Remember, first place cannot be filled by 0 because if the number starts with 0, it will no more be 3-digited, right? It will be no more 4-digited, it will be called 3-digited. So 0 cannot come here. So out of 0 to 9, 0 is gone. So how many numbers are available for the first place? The first place can be filled in 9 ways. Why? Because 0 cannot go there. So 0, 2, 1, 2, 3, there are 10 digits, but 0 is gone. So there are 9 digits available. Now, as far as second digit is concerned, second digit में क्या होता है कि there are 10 digits available right from 0 to 9. But out of that, 1 is already gone here. So that cannot be repeated. So out of 10, 1 is gone. So again here there is 9. Okay. Now you can see that 2 digits are already used, right? Out of 10 digits, 2 digits are already used. So third place can be filled in how many ways? 8 ways. Now 3 digits are used, therefore how many ways you can do it? 7 ways. So the answer is going to be 9 multiplied by 9 multiplied by 8 multiplied by 7. Okay. So that amounts to 81 multiplied by 8 multiplied by 7, which gives me 8. 64 multiplied by 7, that gives me 6. Okay. So this is how the answer is. I will repeat it. I will check again. This is okay. So this is correct. The answer is correct. Okay. Fine. Nice. So now let's go to the next problem. Okay. This is a problem number 3. How many 3-digit even numbers can be made by using the digits 1, 2, 3, 4, 6 and 7? So 1, 2, 3, 4, 6 and 7. So exactly 1, 2, 3, 4, 5, 6. There are 6 digits available. So 6 digits are available. 6 numbers are available. Okay. How many are to be used? Only 3 are to be used. Correct? Now, the condition is that, so 3 are to be used means what? I have to fill up how many places? I have to fill up 3 places. Place number 1, place number 2, place number 3. These are the 3 jobs for us. These 3 jobs are to be done in a particular way. What is that particular way? The condition is that the number has to be even. Now, it's a common knowledge that if the number is even, then the last digit has to be multiple of 2. If the last number is multiple of 2, then how many multiples of 2 are present here? One is 2, another is 4 and another is 6. So last place can be filled by any one of these 3 digits. So that means this place can be filled in 3 ways. This job can be done in 3 ways, right? Now, remaining digits, there is no restriction at all, except repetition is not allowed. So one digit is already used here out of how many? 1, 2, 3, 4, 5, 6 digits, right? 6 में से एक चला गया, तो क्या बाकी हो गया? 5 बाकी हो गया. 2 चले गए, फिर कितना बाकी है? 4 बाकी है, correct? So therefore, this number of so answer is what? Just multiply these two there and then you will get the answer. So it is 4 into 5, 20. 20 multiplied by 3. So this answer is going to be 60. So 60 is the total answer. Okay. Now find the number of 4-digit numbers that can be formed by using the digits 1, 2, 3, 4, 5. If no digit is repeated, how many of these will be even? Fine. So again, I will use the same technique. Number of digits available are 5. 1, 2, 3, 4 and 5. They are available, right? These digits are available. How many digits are to be used at a time? 4-digit number. That means I have to do a job of filling up 4 places. So we'll divide it into 4 jobs, right? The question is, how many such numbers can be formed? And repetition is not allowed. No repetition. Fine. So first place can be filled by any one of these 5. So first job can be completed in 5 ways. But repetition is not allowed. So second place can be filled in 4 ways. Repetition is not allowed. So third place can be done in 3 ways. Repetition is not allowed. So last place can be filled in 2 ways. Okay. So 5 multiplied by 4, 20 multiplied by 6. The answer is 120. 4-digit numbers can be formed. Now, how many of them will be even? Right? Last problem also we solved it. Because the numbers required are even, the last place can be filled only by those digits which are divisible by 2 or multiples of 2. So how many multiples of 2 are there? Only 1 and 4. So now here the last place can be filled in how many ways? 2. Okay. Last place can be filled in how many ways? Only 2 ways. Now this place can be filled in how many ways? Now out of 5, 1 is gone. So therefore this is 4. Out of 5, 2 are gone. So this is 3. Out of 5, this is equal to 2. So therefore 2 multiplied by 3 multiplied by 4 multiplied by 2. So 8 multiplied by 6, 48. So there are exactly 48 numbers which will be even numbers, right? So 48 even numbers. So the answer for this question is 48 and answer for the first question is 120. That's the end of this problem. Okay, fine. Now, look at this problem number 5. From a committee of 8 persons, how many ways we can choose a chairman and a vice chairman, assuming one person cannot hold more than one position. Now, see, for choosing a chairman, how many members are available? 8 members are available, right? And you can choose any one of them as chairman. So chairman can be chosen in 8 ways. Chairman can be chosen in 8 ways. Whereas chairman and vice chairman are not the same person. Therefore, vice chairman can be chosen in 7 ways. So therefore, the total number of pairs of chairman and vice chairman will be 8 multiplied by 7. That is 56. That's all. That is the end of this problem. So 56 is the answer. Okay. Look at the next problem. Yes. Now this problem is slightly different. It involves the notation of permutation and combination. Okay. So let us look at the problem first. Problem is like this. Find the value of n if n minus 1 p3 as to n p4 is equal to 1:9. Now when we say as to, it is a symbol for ratio. That means n minus 1 p3 will go in the numerator and in the denominator you have n p4. Now they have given that this ratio amounts to 1/9, right? Now using this equation, I want to find the value of n. Okay, fine. So I told you that if I want to find out n, p, r, there is one way of doing it like this. You start with n, keep on reducing that number by 1. So n minus 1, n minus 2. How many times you have to do it? R times. Correct? So if I want to find out n minus 1 p3, I will start from n minus 1, go backwards. How many times? 3 times. So therefore it will be like this. N minus 1 multiplied by n minus 2 multiplied by n minus 3. Stop, because we are not allowed to go beyond 3 terms. Okay? In the same manner, if I continue in the denominator, I will start here from n and go on reducing the number by 1. N minus 1, n minus 2 and n minus 3. Stop, because we are allowed only 4 places. Okay? So this is equal to how much? This is equal to 1 upon 9. Right? So now here you can clearly see this n minus 1 gets cancelled, n minus 2 gets cancelled, n minus 3 gets cancelled. What are we left with? We are left with only 1 upon n. 1 upon n is equal to 1 upon 9. So this gives me a clear answer that n is 9. Okay? Now suppose I want to solve this same problem by using the formula. Fine. If you want to use the formula, then n minus 1 p3 can be written as n minus 1 factorial divided by n minus 1 minus 3 factorial divided by, this is numerator, and denominator is n factorial divided by n minus 4 factorial. That is equal to 1 upon 9. Okay. Now, this gives you what? This gives you n minus 4 factorial and denominator also n minus 4 factorial. So let us cancel it right away. Okay. So this part goes. So we are left with only 2 numbers here. N minus 1 factorial divided by n factorial, which is 1 upon 9. Do not forget, when I discussed n factorial, I told you that n factorial can be written as n minus 1 factorial numerator divided by n minus 1 factorial into n. This is equal to 1 upon 9. This whole thing goes. Again 1 upon 9, n is equal to 9. So 1 upon n is equal to 1 upon 9 and n is equal to 9. So you can see this method is slightly longer than this method. So I want you to understand NPR can be written by using formula like this, or it can be written in this manner. This manner is sometimes beneficial, sometimes that formula is beneficial. It depends on the kind of problem that we are solving. Okay, so you can solve this problem in this manner. Okay, fine. Now let us go to the next problem. So the next problem is almost similar. Only thing is, in the last problem we were asked to find out n, but here r is to be found out. Fine. So no change at all. So first part is what? That is the first part. First part is find value of r. If 5pr is equal to 2 times 6pr minus 1. Fine, 5pr is equal to 2 times 6pr minus 1. Now in this problem, it is better to use the formula, right? So 5pr means what? It is 5 factorial divided by 5 minus r factorial. Clear? Okay. Now here, this is equal to what? 2 multiplied by 6 factorial divided by 6 minus r minus 1 factorial. I have to subtract these two. Here also I have subtracted r from 5. Here I have to subtract r minus 1 from 6. Therefore, it is like this. So it is 5 factorial divided by 5 minus r factorial multiplied by 2 multiplied by 6 factorial divided by 6 minus r plus 1, that is 6 minus r plus 1 factorial. Okay, which means 5 factorial divided by 5 minus r factorial, correct? This is equal to 2 multiplied by 6 factorial divided by 7 minus r factorial, because 6 plus 1 is 7. Now you know I can write 6 factorial as what? So I'll do it like this. 5 factorial divided by 5 minus r factorial to 6 factorial can be written as 6 multiplied by 5 factorial, right? Divided by 7 minus r factorial and 5 minus r factorial. So let us go backwards. From 7 minus r, what is the next number? 7 minus r is the first number. What is the next number? It is 6 minus r. Okay. What is the next number? It is 5 minus r. So it is 5 minus r factorial are left here, right? So 7 minus r multiplied by 6 minus r multiplied by 5 minus r factorial. Now there is a lot of cancellation involved here. We'll happily cancel all these terms. 5 factorial here can be cancelled with 5 factorial here. 5 minus r factorial can be cancelled with 5 minus r factorial. So what will be left here? Simply 1, right? And what will be left here? 12, right? 12 divided by 7 minus r and 6 minus r, correct? Which means 7 minus r multiplied by 6 minus r is equal to 12. Now, when you look at this equation, you will be tempted to multiply them. So if you multiply 7 by 6 and all that, you will get a quadratic in r, and then you will have to solve that quadratic. But problem is easier than that. If you apply your common sense, you will realize that these two are not ordinary numbers, they are natural numbers. And natural numbers, one is just one greater than the other. So I have to just factorize 12 in such a way that the two factors will be consecutive numbers, which I already know that the factors are 4 multiplied by 3. So this gives me 7 minus r is 4 and 6 minus r is what? 3. So that means 7 minus r is 4. So 7 minus 4 is r. So r is equal to 3. Correct? So we have found out the value of r. R is what? 3. So that is the first question. Okay. Now let us go to the second one. Second one says that 5p r is equal to 6p r minus 1. Find the value of r again. So now here, let us use the formula. 5 factorial divided by 5 minus r factorial. This is equal to what? 6 factorial divided by 6 minus r minus 1 factorial, right? This means 5 factorial divided by 5 minus r factorial, here 6 factorial multiplied by 6 minus r plus 1 factorial. Okay, that means 5 factorial divided by 5 minus r factorial. This is equal to 6 factorial means what? 6 factorial means 6 multiplied by 5 factorial. Last time also I told you this. So therefore, this is 6 factorial divided by 7 minus r factorial. Okay. So this is how it is. Now, as we did in the last problem, we'll write this as 5 factorial. No change here. Here also there is no change. 5 minus r factorial. This is equal to 6 factorial. But 6 factorial is bigger than 5 factorial. Therefore, it can be written as 6 multiplied by 5 factorial. And here 7 minus r number is bigger than 5 minus r. So I will start counting from 7 minus r backwards. So 7 minus r, then what? 6 minus r, and then comes 5 minus r and all those numbers. So they can be written as 5 minus r factorial. Correct? So now 5 factorial cancels. 5 minus r factorial, 5 minus r factorial cancels. So again, you are left with 1 upon 1 is equal to 6 upon 7 minus r multiplied by 6 minus r, which gives you 7 minus r multiplied by 6 minus r is equal to 6. Don't forget, these numbers are consecutive natural numbers, one after the other. And 6 can be factorized as what? 3 multiplied by 2. So the bigger number will correspond to 3, smaller number will correspond to 2. You can use any one of them to find the value of r. So 7 minus r is 3. Therefore, 7 minus 3 is equal to r. Therefore, r is equal to 4 in the second question. Correct? That answers the second question. Now, how many words with or without meaning can be formed using all the letters of the word equation? Equation. See, the word is equation. EQUATION. Right? How many words with or without meaning? That means the numbers, the words that you're going to form may not mean anything. I mean, there are some gibberish, okay? So we are not interested in the meanings because the words may not be meaningful at all. We are just using them as an object. So this is one object, second, third, fourth, 5, 6, 7, 8 objects are there, correct? And we want to arrange them, correct? And we want to arrange them and we have to find out how many words can be formed, okay? And one more condition here, one letter can be used exactly once, okay? So the problem is actually equivalent to, there are 1, 2, 3, 4, 5, 6, 7, 8 letters are there. And all these 8 letters are to be arranged in a straight line. So the problem is equivalent to solving 8p8. All 8 are to be used and therefore 8p8 is equal to nothing but 8 factorial divided by 8 minus 8 factorial, right? Which gives you 8 factorial divided by 0 factorial. You all know that 8 factorial upon 0 factorial is 1. So therefore the answer is 8 factorial, correct? So that is the answer. Or if you want to use multiplication principle and without using 8p8, then there are 8 places to be filled. 1, 2, 3, 4, 5, 6, 7 and 8. First place can be filled in 8 ways. 7, 6, 5, 4, 3, 2, 1. This is exactly what? 8 factorial. So the answer doesn't change. You can do it by this method or by this method. Is one and the same thing. Now, let us do the next problem. Next problem is, let us have a look at it. How many words with or without meaning can be made from the letters of the word Monday? Right? Assuming that no letter is repeated. Okay. So we have how many letters are available? Available are M, comma, O, comma, N, comma, D, comma, A, comma, Y. For us, they are just objects, nothing else. They may be words or numbers, whatever. Now, no letter is to be repeated, okay? That has to be taken into account, first of all. And 4 letters are to be used at a time. That means out of 1, 2, 3, 4, 5, 6, how many letters are to be used? Only 4, correct? So the problem can be written as 1, 2, 3, 4, 5 and 6. So there are 6 letters available, right? And how many letters are to be arranged? Only 4 at a time. So the answer is 6p4. 6p4. Now 6p4 can be written as 6 factorial divided by 6 minus 4 factorial. This is equal to 6 factorial upon 2 factorial. And 6 factorial means what? 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Right? And 2 factorial means 2 into 1. So this 2, 1 gets cancelled. So remaining is the answer. So 6 into 5, that is 30. 30 multiplied by 12. So that means 360 is the answer for the first question. Okay. All letters are to be used at a time. All letters are to be used means what? The answer is what is 6p6. Because all letters are to be used. Fine. 6p6 is equal to what? 6 factorial upon 6 minus 0 factorial, which is nothing but 6 factorial, right? 6 factorial turns out to be what? 5 factorial is 120. So it will be 720. Because 5 factorial is 120 multiplied by 6. So 12 multiplied by 6. That is 720. This is the answer. All letters are to be used, but the first letter has to be a vowel. Oh, that's good. So that means, see, all letters are used, but first letter First letter has to be a vowel. Now, how many vowels are there? A, E, I, O, U. They are all vowels. A, E, I, O, U. These are vowels. Out of these vowels, how many vowels are present here? There is O here and there is A here, right? So there are only two vowels present in the given set of letters. Fine. So all letters have to be used. The first letter is vowel. So we have to use all letters. That means we have to fill up how many places? 1, 2, 3, 4, 5 and 6. 6 places have to be filled. But the first letter must be a vowel. That means first letter can be chosen only out of these two, right? So the first place can be done, filled in two ways. And then there are no restriction except no letter is repeated. So that means out of these 6 letters, one is gone. So here it is 5, 4, 3, 2 and 1. Correct? So the answer is 2 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which gives you what? 10. And this is 6 multiplied by 4, that is 24. So the answer is 240. Okay. So that is the answer to the third question. Okay. So let us start this problem. Before the start of this problem, I want to introduce one formula. Formula is this, that if in the given set of objects, one object A1 repeats R1 times, A2 repeats R2 times, A3 repeats R3 times, then total number of permutations are given by R1 plus R2 plus R3 factorial divided by R factorial, R1 factorial, R2 factorial, R3 factorial. Correct? So this is how the repeated permutations is to be applied. Why? Because if the same letter is repeated, it cannot be permuted. It amounts to only same number, same letter. Okay. So therefore, this formula I am going to apply for solving this problem. Here, there are exactly 4 letters here. M. Then we have I. Then we have S. And then we have P. So there is no other letter except these 4. Only thing is, M is repeated how many times? Only once. I is repeated how many times? 1, 2, 3, 4. 4 times. S is repeated how many times? Again 4 times. And P is repeated how many times? Twice. So 4 plus 4, 8 plus 1, 9 to 11. So that accounts for all the 11 letters here. Total number is 1 plus 4 plus 4 plus 2 factorial divided by 1 factorial, 4 factorial, 4 factorial and 2 factorial. So that gives me 11 factorial divided by 1 factorial is anyway 1. So it is 4 factorial into 4 factorial into 2 factorial. The actual numerical calculation is left to you. You can complete it. Okay, fine.